I can see
Can
it.
you see the screen?
Yeah, yeah.
So what are you seeing?
I can
The
see
Python book?
your browser.
Okay.
Yeah, I can see the Jupyter notebook.
Yeah. So I did it a bit differently, but it's basically the same. So I had these numbers in an array, and then this is the path, and I wrote a method which basically so I did a lot of method definitions instead of writing down, and
Okay.
I train it for few with the basic optimizer and with the neural net. And at the end of the day, like the had a definite an exercise of creating your own learner, and I did that. Uh, I got 97%. It's basically a copy of what the book was basically like, fitting all the thing that I had learned into my own learner class. Uh, so that was the end goal. Okay, so here I have like, so we are doing a number. So our sample contains 3 and 7, right?
Right.
So I put those into an array so that this can be scaled up later, right, if needed. And this is the path for sample the data. Okay,
Mm-hmm.
and this is a method which basically converts if I whatever data set
Yeah.
I send,
Right.
yeah,
It will
it
then
will
analyze.
convert it to the stack dot tensor stack. So basically what it does is this is the path, right? This is the image path for each. So this is an ls, so it will display all that, so it will become an array.
Mm.
And then this is the image for each of the image. Image opening it, and
And then convert it into
tensor, I'm moving it to a tensor. Sorry, I'm converting a tensor, and for all the ones that are there, at one point of time I'm directly converting it to float of. I'm normalizing it basically,
right.
converting it to a float and normalizing it.
Right.
So so if you want to see an example of this, I just if I just do this, I just send a train 3 path. Why is it taking so much time? Oh yeah, it will take some time. I think this is the part that takes time. So it
I think
will
you're doing all the files right now for train 3, right?
yeah. So for also this is an tensor of at the end of this. So, this method will basically return me a tensor of size 630,
Yeah.
a stack of 631 by 28 by 28 images. Right,
Right.
that's the size of the image. Okay, and now what I did was, just so that it will scale well, I created a dictionary of tensors. Right, so I will have something like uh, let me show you. So it will have like, it will have 3. Okay, 3, and it will have a training set and a validation set. So
Okay.
this is what, this is what it is basically. So it creates a dictionary of tensors. So the key is the number string converted, and then this is the training path, and this
Mm-hmm.
is the validation path.
Okay.
And this will actually happen for each of the numbers that is passed. So for each of the numbers that is passed, this will create this dictionary. So this way, I basically, it was a way for me to have the train and the validation at one place. So we have a for 3 data set, for 7 data set, for 9 data sets, so that I can work with them independently as well.
Is it
So mhm,
so? Uh,
yeah.
how is it iterating on the numbers?
So this is the array that I passed, right?
Right.
So for each number, okay, why did it do only for 3? Oh, okay.
Yes.
I printed only for 3. Okay, so this is just some small example. So for number in numbers, whatever is done, so I pass this method a path and numbers array. Okay, so
Right.
basically numbers is at this point 3, 7,
Right.
right?
3 cents.
And the path is, this is the path, right?
Mm-hmm.
So I pass this path, and in this case, I just, for this example, I had just given a 3. But even if I do a 7,
No, I was confused about the function. So in the function, it shouldn't be for number in numbers, right?
yeah, for number in numbers.
Because in the function, you're only doing it for one number at a time.
Oh, this one.
No, the one underneath.
So
This
okay,
one.
this will like for each number. So it will create a dictionary, right? I'm not creating a list. I'm creating a dictionary for
Is it
each
similar
number
to
and
that? Is it similar to? Is this similar to how you do it for dictionary for lists?
yeah. So at the end of the day, this is how it will happen. So this will come. So okay. So let me tell you. For example, if I do x for x in range of 10, right, or let's say 5,
Right.
right? So this will give me an output of
0 to 5, 0 to 4.
0, 1, 2, 3, 4, right?
Right.
Now this is a list comprehension. And what I used was this uh, a dictionary comprehension. So if you do this, so for example, you have to dictionary has a key value pair, right?
Okay.
So string x uh, plus suppose 20. Yeah.
Right.
Sorry. Okay, and then for x in range 5. Okay.
Okay.
So what this will do is 0, 20.
Oh, okay.
Oh,
All
it's
right.
no, not 0, 2, 0, and then 1, 1, 2, 0,
Right.
2,
Got it.
2, 2, 0.
Got it.
So that's what it does basically.
Okay, I wasn't
Dictionary.
aware of dictionary comprehensions.
Yeah. So this is basically what it does. It returns a dictionary comprehension, and so if I process number 3, it does this.
Okay.
So that way, like, I think this is all because so that it will scale well. And that's all it
Right.
does. And then what I am doing here, this is another method that I've written, which it takes a dictionary, yeah, and a batch size input and whether shuffle or not, and then it will uh, return the training and the validation data loader. So these are all tensors, right? This is all at the end of the day, it's a tensor, right? Whatever it printed, it was a tensor.
Right.
So this what it will go, it will get a valid data loader so that we can batch it.
So you have what the input is a tensor dictionary that you created above.
Yeah. So I
And,
pass in the dictionary dense, whatever I created above, right?
right.
And batch size and shuffle is equal to true or false.
Right.
And so for example, here it will iterate through each items, for example, 3 or 7.
Mm-hmm.
And so this is the tensor size. So basically whatever the size, for example, in this case, it was
Right.
613 items and stuff like that, right?
Right.
And then it will basically put it in an array. Train
Okay.
X is a blank array, and then I put all the items of this tensor into here. So this will happen for each of the items. There is a train
Each of
tensor
the
and this is a
right.
valid tensor.
Right.
So and here this is the one example that I have to change for when I do multi-tensor, multi-category. I just have to remove this. But right now, because it's only a binary, I have converted into 0 and 1. So 3 will have 0, mod 3 0, and this mod 3 is 1. So it's a
Okay.
combination of zeros and ones for now.
Okay.
And then I put everything into for training and validation.
Mm-hmm.
I think I can, yeah. I have put it basically into a concatenation. So I have put them into a torch and resized it.
Yeah.
Yeah. So right now, so here they were of size of, for example, 61312828, right?
Mm-hmm.
For example, if we just two puts 3, it will become 6131 into 784. If
Right.
only x3 is there. If there are
Right.
7 in 7, for example, there are 100 more, then it will become 6231 into 784.
Yeah. Right.
And here basically we are creating a row tensor, sorry, a column tensor of train Y items.
Mm-hmm.
Yeah, similarly for the validation and the
And then you're putting them into
validation,
data loader, and then that becomes
and
the.
I'm converting into a zip and then a list, and I'm according to the batch size, I'm converting it to train data loader and valid data loader, and then returning this data set.
Right. Nice.
Yeah. So, and then this is the init params method, which basically creates a random size, creates random parameters of size and standard deviation, whatever you have passed. So there is a case in the example. Okay, so when I had first done this, okay, I had a passed in this like this init params 4,1. Can you see
I
the
think
difference between these two?
we discussed it last time.
Yeah. So the difference
Yeah.
between the two is this one will create a one row tensor, and this is basic. Sorry. This will create a column tensor. It's a row tensor, right? It has just one row. Okay, and whereas this will have one column. I will show you this too. This was pretty. Uh, uh, so see, this first example is a column tensor, and this is a row tensor, or whatever it is. This has just one column. So we need our parameters in such a way, right? Because it will multiply easily. Otherwise, you have to take a transpose of it. So if you do like this, you just have to take a transpose of it. So that's a difference why it was not getting calculated.
Okay.
So this example was there. And this is the MNIST loss function where if it is upon a sigmoid.
Right.
And then this is the matrix multiplication. And I just have this one done so that I can reuse a lot of stuff without just doing a loss function is equal to new loss function. Then I can play around with anything. I don't have to write the train epoch model or stuff like that multiple times. Okay, and this is the model matrix multiplication. Pretty simple. And this is the calculation gradient calculation. I did in my manual. So you predict the model, whatever the predict models, and then you calculate the loss function, and you do a backward propagation, right?
Right.
And this is the optimizer that was managed basically for the parameters, like parameters and the bias. You learn, you adjust your weights according to the gradient and learning rate,
Right.
and then you change the gradient to 0,
Right.
so that it does not get saved and get reused in the later part, in the later calculation. And then, so train epoch is basically you, for each batch in the data loader, you calculate the gradient and you optimize. That's all we do in the train epoch. So that
Right.
way the parameters keeps on changing.
Mm-hmm.
And the batch accuracy, it's all about, so batch accuracy is like
Getting
whether
the
your
accurate
prediction,
performance.
you convert it to a sigmoid, and like if it's greater than 0.5, is it 1? That's all.
Right.
Like if it is greater than so if it is greater than 0 point, it's a 1, and is your prediction y equals to actual 1. And then for all of the items you do that, so you convert to a float dot mean. And so this is a tensor. So when you do a float dot mean, it's a tensor, right?
Okay.
So to convert it into a numeric so that we can use it, we have to do a dot item. Okay, I found it the hard way actually. I had not written this. I had just written this one mean, and then somewhere down
Right.
the line there was everything was not a number. Then I figured out that okay, we have to convert it to a numeric. So dot item will get the numeric value, and then just for looking at it easy, I have rounded it up to 4 digits.
Okay.
Okay, and
Okay. Yeah.
yeah, and so this has my metric by default is batch accuracy, and this is the validate accuracy, which basically will be basically np dot mean of whatever is like in each batch. We sum up the batch stuff, and the initialize param just creates a parameters array and a bias.
All right.
And
And
train
you're
model
using
base.
init params that you defined earlier.
Sorry.
And you're using init params that you defined earlier.
Sorry.
You're using the
Yeah,
functions init
I just
params that you
defined the
defined
same
earlier.
process. Yes. This is being, I think, somewhere above. Somewhere, yeah. This is the init params.
Yeah.
So it's just that, so I don't have to write 2 times. I can just do this.
Right.
That's all it is.
Mm-hmm.
And yeah, so and this is I convert it and I again tuple it, because that is how it expects for SGD and for stuff and like that. So the learning rate is so it's very interesting. Let me run till here, and I'll tell you how the learning rate actually matters till now. Run cells, run all above. Yeah, it's run. It's run, right?
Yeah.
Yeah, I think it's run. Yeah. So very interesting. If I do a learning rate of 1, okay, this will take a bit of time actually, because trained DL and valid DL are being created here.
Mm-hmm.
Let me do this here. Uh, Next time it will be faster. So this is the one. So it will convert it to tensor and stuff. Okay. So if I do this, yeah. Why is it taking? Oh, yeah. See the accuracy. Interesting. Hold on. Okay. If I do a learning rate of 1.0, oh, so it was learning. You know, when I first did it, when I
Maybe you
first
can
did it was,
increase it further.
yeah. So uh, oh, sorry. When I did a learning rate of 0.01, it does not learn. Does not learn. It learns very slowly, like even
Right.
after 20 epochs. So
Yeah.
ideally, I've heard that so I had done a bit of researching, and like this is not a hard and fast rule, but like 10 to the power minus 3 is a good learning rate. So 0.001. But for this
Okay.
case, like if you do 0.01, 1 of 100, then the learning rate is not good.
A
Then
good practice is to have what do you call it? Reducing learning rates, where you have a
yeah,
high learning rate at the start and then it keeps on reducing after each epoch or a
yeah,
certain number of epochs.
yeah, that's right. So actually, Jeremy discussed this in chapter 5 or 6. He discussed
Okay.
like in some video. He actually there is the learner that Fast.ai provides. There is a
Mm.
uh, learning rate finder as well.
Right. LR find.
ELR find, yeah.
Yeah.
So this is one. So if I convert it to 0.1, if you see it scales up a bit more nicely, and
Right.
if you increase it to 1, it is a bit more scalable. So it arrives 97% fast. But if I do this, it does. So I mean, it has not deteriorated yet,
Right.
uh, but yeah, it's a training data set. I mean, it may. So I have generally kept it at around 0.1, and this is the result that I get.
Mm-hmm.
And then basically I had created this basic optimizer, and so we so basically it's the class version of this, rather than uh, having to do this one optimize manual. We divided it into two things. So basic optimizer, and you basically create an optimizer which will do that. Okay. And rather than doing it manually, you have to do it, you define the functions in the step and the zero grad. And one interesting thing here about is that you don't, so your parameters you initialize inside only, so that you can play with it here. So, and here we use the linear model, nn.linear, which is basically a linear model, like one neural network. And this creates parameters also, like instead of having us to do the initialize params, it will create this by itself. Like you don't have to do it, it will create its own. And if I run this, okay, I have to run this.
Run the basic optimizer.
Yeah.
Yeah.
So, and I just, so as the optimizer that I had done previously, it was a different one. And now I change it to this part. Optimize is equal to this function. So that was the reason I was doing this, writing this one line here, so that I can use this train epoch and validate model, train model. I don't have to rewrite it for changes.
Mm-hmm.
So I did, this is the optimizer functions, basic optimizer function, and like I created this basic optimizer. So once I run this, with the learning rate, I think is the similar that I had passed in earlier, 0.1.
Okay.
With that, it gave me slightly better, not much, but slightly better results. Oh no, it should be the same. Yeah, it's similar, because at the end of the day, it's same function, right? I'm just
Right.
passing it into a. Why did I copy this stuff? Okay. Oh, this is the SGD. Sorry. This is the basic optimizer that I ran, and it gave me slightly different results. So 0.9373, and this is around 0.9725. And then in this case, I use the optimizer of the SGD, optimizer, yeah,
Okay.
and I trained the model with it. So I got the same result. So which tells us
Shouldn't
this,
shouldn't it be a slightly different from the previous one, because when you're initializing the parameters, you might get different parameters in
like
the second.
it's initializing the parameters every time, right?
Yeah, I mean, if you these are random initializations, right? Or
Yes, yes.
then the random stuff can be slightly different,
Yeah,
or
see, so it's after epoch 1, it is like 0.43. It ends up being the
is it,
same.
yeah, it ends
It
up being the
starts,
same. Initially, it's different. Yeah,
it's
right.
different, 0.877.
Yeah,
It's like around third, I think it starts to merge,
yes,
0.9366745, somewhere around
makes
third
sense.
or fourth epoch. So I think at some point like, I think it's very, yeah, it's random by a slight amount. So it merges around fourth or fifth iteration.
Right,
And then use I just converted this to data loaders, and using the learner function that we had, I did the same thing, learner.fit 20. So this is the learner that Fast.ai provides.
right,
This is the data loader, and this is the model that we provided. This is the opt function. This is the loss function. This whatever the matrix, and it almost gave us similar results because the function is all similar. Just we are using an inbuilt learner method.
right.
So the
Is this covered in chapter 4?
yeah, this is covered in chapter.
Okay.
And so that's all there was. Yeah. And so this was basically data loaders and stuff like that. So I ran it. It approximately the same result. The time it takes is shown here. This is, of course, learner has a print method which is way better than my accuracy
Yeah.
one liner. And this was a different model that I created, like that, like as per the first. Okay, I have not run this. It takes a while. Yeah, so approximately it's 9.973513. Approximately the same of this.
Mm-hmm.
And then this is the one where like there is a bit of non-linearity to it. I have like multiple layers, layer 1, and then there's a non-linearity, and there's a second layer, again a non-linearity, and this is my final layer. So with like 5 layers, instead of this being one here, like this
Mm-hmm.
was just a one layer,
Yeah.
we got a result of 97.3, and with 5 layers we got a 97.8. So
Okay.
not much of difference. So which means that I think a single layer is a bit more faster, I believe, with single layer rather than having to go through multiple layers. But I think we can get the same. The difference is that we can get it in faster rather
Right.
than having to wait for it.
Yeah.
And this is the plot of how it learned. So basically, you see around third iteration itself, we had already, fifth iteration, we had already peaked around 95%. And that after that, it was learning pretty slowly.
Pretty slowly.
So that's all basically book examples. And the book had an exercise of creating your own learner. So this is my learner. It's nothing. It's just using all the data above and putting it into one fit method.
Okay. Did you
And
test it on a test set as well?
was there a test set? Oh, no. Yeah, so that I have to modify it for the test set, but yeah, for
Okay.
the 410 and all. Uh, oh shit. So that was my basically, yeah.
Nice. I still need to do something like this. I mean, I keep looking at
So
things.
this test data is in MNIST movie. Where is it? Or like we have
No,
to download
I'm
it.
not sure if there is if there's a test set. I
Okay.
meant that did you create a test set and then test the performance on that on the side?
Oh, no. I haven't done that. No.
But you're doing it on validation set. That's more or less the same thing.
Yeah, I mean, yeah, like I don't have. Yeah, that would be a good thing. I think that this is anyway a small set. I think
Yeah.
I'll try it with 5 and 8
Okay.
next. Like I was
Yeah,
planning to
they're
download
pretty
this
similar.
5 and 8. 5 and 8 is the one. So 1 and 7, 5 and 8. Those are the
Maybe all
things.
of them at the same time.
Yeah, that is my next goal. So when multi-category, right now I'm learning through multi-category. So
Mm.
once I'm done with the multi-category, that's when I'll be able to do this multi-category stuff.
Okay.
So chapter 5 is about pet breeds a little bit. This chapter 6 is interesting for multi-category, right? If you have multiple categories,
Yeah.
that's when how you will do and stuff like that. So that's interesting.
Okay.
And yeah, softmax function comes in picture rather than sigmoid.
All right. Okay. I need to go through that stuff. I, I feel bad for myself. I haven't done much yet.
No, I
With
think
that
you have taken part. I think top 10, right?
top 10%.
Yeah, like that's huge, right?
I
I
mean,
haven't
but
even started.
everyone, it was the same for everyone. Like everyone got there from 1500, so it wasn't such a big deal.
I
But
mean,
yeah, I still was excited that I
oh
did
yeah,
not.
like I don't even have the guts to do it. So
I'm not sure if it really means that much though, because everyone
no, you
had the
you
same.
took the initiative. That matters a lot.
Yeah,
I'm still
it does, motivate me to participate in more category competitions though. Okay,
okay. No,
cool.
this is yeah, cool. So this is all that I had to show for this. Uh, yeah, class. It's not much.
I'll probably try to go through 2 chapters this week, and then next week we'll have more to talk about.
Yeah, I think. Yeah, I think chapter 4 and 5, or maybe 6 is a good one. So we can. 5 is not that difficult. 5 is more about. Okay, you have watched the video, right? So you might know what 5 is about. Oh, no, this is not the 5. Yeah. Okay.
Okay,
Anything
and I
you
also
want?
I also worked on this data set for chess predictions. So I was interviewing with the company, and then they shared this data set where they had
Mm-hmm.
provided me game results for chess
Uh-huh.
tournaments,
Okay.
and, and so they had provided me historical data for like 5 years,
Mm-hmm.
2014 2019, and all
Okay.
the chess tournaments that happened in that period and who were the opponents and everything. And
Mm-hmm.
then they wanted me to make predictions for tournaments that are going to happen in 2020. So tournaments that happen in the first 3 months of 2020. So I
Oh,
was working
nice.
on that project. It so happened that my validation set in that particular assignment got a
Mm.
score of like 70%, 60. So I used 2 models. I used a random forest, and then I also used a tabular learner from Fast.ai. So the
Okay.
random forest gave me like 64% on the validation set, and the tabular learner provided like 68% on the validation set.
Cool.
But
So I
on
mean,
the
yeah.
test, yeah, yeah, on the test set, though, I did not have the results, right? So I shared the results with them, and they told me that the results on the test set was just 39%, which was way less than what I had expected.
Mm.
So, I mean, yeah, that's something that I would want to share. I'm not supposed to share the data set and everything as part of some NDA that
I,
I have.
yeah, I think we can get. I mean, that's a publicly available data set. Might be.
Yeah, It was an interesting project because the features that I created, I ended up creating like 100 features for that
Mm-hmm.
data set for each white player. What was their history as white player? For each
Okay.
pair of opponents, how many games that they play together, who won most of the games, and who won as white, who won as black, and something like that. Like a whole list of features, and then yeah, so that was an interesting
Oh,
project to work on. It took me a week to actually get that working.
nice. That's really nice.
Yeah,
Uh, yeah.
cool
Cool.
then, Sham.
Yep. Yep.
We probably need to see talk
Yeah.
next week, and
Next week. Yeah.
yeah, okay.
Hey,
Yeah.
Ocean. So do you have any like data sets like where I can? Okay, I think I can get on Kaggle, right? This stuff.
You can
I
get
think around
Kaggle.
next
Yeah,
month, like starting from November, I was planning to get my hands dirty. So I think once this video, like I will go through 6 or 7. I think after that I'll start getting my hands a bit dirty on the because I'll have some bandwidth then, some time from my work stuff, so I'll be able to work on stuff. So
you can
Kaggle
also
would be a
work
good
on
place.
your pet project
Yeah,
of
I'll do that.
classifying.
But the thing is, I don't have a machine good enough, and then I have to pass data. Like I have to upload the data to the server, my
I don't
private
think you need
photos.
to do that. You could do it on your CPU as well. I mean,
But
training.
like yeah, no train. But for training, I have to do it here, right? I can't.
No, no, you can do it on your CPU as well. I do all my stuff on my CPU only. It just takes like for the learner to fit, it might take like a few seconds on the GPU, and with my CPU, it would take like a couple of minutes because there are not a lot of training samples that I have, so I do not really have
Okay,
too
so
much.
that's all. It's a difference of minutes.
I mean, it's a difference of like 10, 1500 times, right? But on a
Okay.
GPU, if it's like 10, 15 seconds, on my CPU, it takes like 2, 3 minutes.
Okay. I tried
But
to set up, okay, but like it takes a lot of time for the examples. I think there were a lot of examples for the grizzly and stuff. So I'm just gave it up
yeah,
and then I signed for paper space. Otherwise, I was doing it on my
okay.
um, local at first.
Yeah, if
I have
something
a
takes
small
like,
GPU. I have a
yeah,
small GPU, NVIDIA GPU. Like it
okay,
has a rating of 2.5 out of 8 on the NVIDIA website.
okay. But it's still
So
a GPU with a lot of cores.
yeah,
Should be able to
I
facilitate
don't
it.
think there's a lot of cores. I think there are 8 CUDA cores or something like that. The recent ones have like 400 or 4,000 or something like that, but mine has around 8 or 16 CUDA cores.
Okay, okay. Yeah, but
Yeah,
if a learning
it's
exercise takes like minutes on the GPU, like paper space, then it
yeah,
would take a long time on your
yep,
system. But if it's like something very quick on the GPU, then you could probably run it on your CPU as well with a couple of
yeah,
minutes of
yep. Probably do will do
okay.
that.
All right. Cool.
Cool,
Thanks
man.
for showcasing your work, Sham.